So in the last video we talked about graphing inequalities like this one, where you have a dashed or solid line and then you shade above or below. In this video we're going to talk about systems of inequalities. So just like systems of equations, a system of inequalities is multiple inequalities. That's all a system means, is have more than one. So what you'll do is basically just graph both of them and see where they intersect. Just like with systems of equations, you graph the two equations and see where they intersect. With inequalities, you have one shaded region and another shaded region, and you see where those regions overlap. Okay, so this one we graphed in the last video. You got to subtract x from both sides to get y by itself. So y is less than or equal to negative x plus 3. This has a y-intercept of 3 and a slope of negative 1. So down 1 over 1, down 1 over 1. It's a solid line because it could equal the line. And I'm going to shade below it because it's less than, so we'll shade below. So that's the first inequality. The second inequality I'm going to do in blue, and this one is a little weird. Imagine if I just had x equals negative 1. This is a vertical line because if I go to where x is negative 1, that happens here. And also here, x is still negative 1, and here and here and here. It's a vertical line. One way that I remember this is an x kind of looks like two v's for vertical. But it wasn't equal to, it was actually just greater than. So instead of doing a solid line, I should have done a dashed line. Let me get my eraser and erase. Oh no, it's too big. Erase little pieces of this to make it a dashed line. There we go. Good enough. And so now that I have my dashed line, I need to figure out which way to shade. This one's a little different from ones we've been doing because there's no above or below the line, it's just a vertical line. I want values that are greater than negative 1, so which way do you think I'm going to shade? You probably guessed that I'll shade to the right, and that is true, because all these are the x values that are greater than negative 1. If you weren't sure about that, another way to figure it out is just pick a point. Like this right here. Is 0 greater than negative 1? Yeah. Is negative 4 greater than negative 1? No. So we don't shade that way, we shade this way. You may notice now that I have the red shaded region and the blue shaded region, and the region where they overlap is the answer to the entire system. I'm going to make it a little darker here with purple. So this region right here where the blue and the red overlap is the solution for this system of inequalities. Every single point in this region solves that system, including the points on this line because it's solid, but not including the points on this line because it's dashed. So for example, that point would work for both of these. This point would work for both of these. This point would not. This point would only work for the first one, not the second one. This point would only work for the second, not the first. And a point over here would work for neither. Let's try another one. I think this is our last one. Yeah. So on this one, the first one I'm going to do in red again. Do this one in red. This is a horizontal line, because if I go to where y is negative 1, that happens here, and here, and here. Y kind of looks like an upside down H for horizontal. It's a horizontal line, and it's solid because there's an equal to there. And since it's greater than, I'm going to shade above. Okay? For the next one, I'll do in blue. This next one here, we're going to need to solve for y in order to graph it. So subtract 3x from both sides, just trying to get y by itself. So negative 3x plus 2, that doesn't combine, those are not like terms. To finish this up, I'll divide by negative 2. But be careful, remember with inequalities, if you ever divide or multiply by a negative, it flips the sign. So instead of less than, it's now greater than or equal to. I'm going to go ahead and break this up a little bit. So negative 3 over negative 2 is basically just 3 over 2x. And 2 over negative 2 is negative 1. Now that I have y by itself, I can graph that line. So the y-intercept is negative 1, that's here. The slope is 3/2, so up 3 over 2. Up 3 over 2. Up 3 over 2. Or you could leave it as negative negative and go down 3, left 2. Down 3, left 2. It's a solid line because it is equal to the line. And I'm going to shade above it because it is now a greater than. It was a less than, but now it's a greater than. So I'm going to shade above the line. And so wherever they intersect, those two regions, is the solution to the entire system. So this region from like here to here and all of this stuff where they intersect. For example, if I picked like -1, -1, or let's pick something easier like 1, 3. No, that's 1, 2, sorry. 1, 2 should work. Is 2 greater than or equal to -1? Yes. And is 3 times 1 minus 2 times 2, which is 3 minus 4, which is -1, is that less than or equal to 2? Yes. So basically, everything along this line, along that line, and within this region should work for both. A point here would only work for the red one, a point here would only work for the blue one, and a point here would work for neither.